The universe is filled with wonders, galaxies spiral in the vast cosmic expanse, stars ignite and burn with incredible energy, and on at least one planet, life has emerged, evolving over billions of years into a breathtaking array of forms. But now, we stand at the cusp of something new, something different. We are no longer simply witnesses to the grand unfolding of life's story. We are becoming its authors. Genetic engineering is giving us the power to rewrite the very code of life. Imagine a world where diseases are eradicated before they strike. Picture crops engineered to thrive in harsh conditions, feeding a hungry planet. Consider the possibility of extending human lifespans, pushing the boundaries of our mortality. This isn't science fiction, it's the future unfolding before our very eyes. The choices we make today will shape the destiny of life on Earth for generations to come. The journey into the future of genetic engineering has begun. Life, in all its diversity and complexity, is governed by a simple yet elegant molecule: DNA. This double helix, a twisted ladder of chemical building blocks, carries the instructions for building every living organism on Earth. For millennia, these instructions have been passed down from generation to generation, shaping the tapestry of life as we know it. But now, we have the ability to read this code, to understand its language, and even to rewrite it. Genetic engineering is the process of altering an organism's DNA to produce desired traits. Think of it as editing the blueprint of life itself. The tools of this trade are precise and powerful, like molecular scissors that can snip and paste segments of genetic code. One such tool, CRISPR-Cas9, has revolutionized the field, making gene editing faster, cheaper, and more accurate than ever before. With CRISPR, scientists can target specific genes within an organism's DNA and make precise changes. This technology has the potential to cure genetic diseases, enhance crop yields, and even reshape the evolutionary trajectory of species. The possibilities, it seems, are limitless. For centuries, humanity has been plagued by disease. From the Black Death to smallpox, from cancer to HIV, illness has cast a long shadow over human history. But now, on the horizon of medical science, a new dawn is breaking. Genetic engineering promises to revolutionize healthcare, offering hope for cures and treatments where once there were none. Imagine a world where genetic diseases like cystic fibrosis, Huntington's disease, and sickle cell anemia are eradicated before a child is even born. Gene editing techniques like CRISPR offer the potential to correct these genetic defects at their source, replacing faulty genes with healthy ones. This could profoundly impact the lives of millions, freeing future generations from the burden of inherited diseases. Scientists are exploring its potential to treat a wide range of diseases, from cancer to heart disease to Alzheimer's. The dream of a future free from the suffering caused by disease may soon be within reach. Since the dawn of agriculture, humans have sought to cultivate crops that are more productive, more resilient, and more nutritious. We've selectively bred plants for millennia, shaping them to suit our needs and tastes. But now, genetic engineering is poised to revolutionize agriculture in ways we could only have imagined before. Imagine fields of golden wheat, genetically engineered to resist drought and pests, producing abundant harvests even in the harshest of climates. Picture rice paddies teeming with grains fortified with essential vitamins, combating malnutrition in developing countries. Envision fruits and vegetables engineered for enhanced flavor, freshness, and shelf life, reducing food waste and improving access to nutritious food for all. By introducing beneficial genes into crops, scientists can enhance their resistance to disease, pests, and environmental stresses. They can increase yields, improve nutritional content, and even reduce the need for pesticides and herbicides, leading to more sustainable and environmentally friendly farming practices. Genetic engineering offers a powerful tool to increase food production, improve crop resilience, and ensure that everyone has access to safe, nutritious, and affordable food. Section 5. Nature's Delicate Balance. As we marvel at the potential of genetic engineering, we must also acknowledge the profound ethical and ecological concerns it raises. Life on Earth is a complex and interconnected web, and even small changes to one part of the ecosystem can have ripple effects that are difficult to predict. One concern is the potential for unintended consequences. Genetically modified organisms, or GMOs, could interbreed with wild relatives, leading to the spread of modified genes into natural populations. This could disrupt ecosystems, threaten biodiversity, and have unforeseen consequences for the delicate balance of nature. Who will have access to these powerful genetic engineering technologies? Will they be used responsibly and ethically, or will they be exploited for profit or even malicious purposes? The future of life on Earth may very well depend on the choices we make today. Section 6. Sculpting Ourselves. Perhaps the most profound and controversial application of genetic engineering lies in its potential to alter the very fabric of humanity itself. Imagine a future where parents can select the traits of their children, choosing their eye color, height, intelligence, and even their predisposition to certain diseases. This is the promise and the peril of human germline editing, the modification of genes that are passed down to future generations. While the technology for human germline editing is still in its infancy, it raises profound ethical questions about human nature, diversity, and the very definition of what it means to be human. Beyond germline editing, genetic engineering could be used to enhance human capabilities in myriad ways. Imagine athletes with enhanced strength and endurance, soldiers with increased pain tolerance and resilience, or scientists with heightened cognitive abilities. As we contemplate the future of human evolution, we must ask ourselves, what does it mean to be human in the age of genetic engineering? Section 7. Life Reimagined. Beyond the familiar plants and animals that inhabit our planet, genetic engineering holds the potential to create entirely new forms of life. Synthetic biology, a field at the intersection of biology and engineering, seeks to design and build biological systems that do not exist in nature. Imagine microorganisms engineered to clean up oil spills, produce biofuels, or manufacture life-saving drugs. Picture plants that glow in the dark, detect explosives, or filter pollutants from the air. The creation of synthetic life forms raises profound philosophical and ethical questions. Section 8. The Elixir of Youth. The quest for immortality is as old as human civilization itself. From the fountain of youth to the philosopher's stone, humans have long sought ways to cheat death and extend their lifespans. Now, with the advent of genetic engineering, the dream of conquering aging may be closer than ever before. Scientists are beginning to unravel the genetic secrets of aging, identifying genes that control lifespan and cellular processes that contribute to age-related decline. By manipulating these genes and pathways, researchers hope to slow down or even reverse the aging process, extending human lifespans significantly. Imagine a future where people live healthy, active lives well into their hundreds, their minds and bodies still sharp and vibrant. But the extension of human lifespan also raises ethical and social challenges. Section 9. A world transformed. The transformative potential of genetic engineering extends far beyond the realms of medicine, agriculture, and even human biology. It has the power to reshape our societies, our economies, and our very understanding of what it means to be human in the 21st century. The rise of personalized medicine, where treatments are tailored to an individual's unique genetic makeup, could revolutionize healthcare. Imagine a world where doctors can predict your risk of developing certain diseases and prescribe preventive measures or early interventions based on your genetic profile. The development of new biomaterials and biotechnologies could lead to breakthroughs in manufacturing, energy production, and environmental remediation. Imagine self-repairing materials, bio-based fuels, and microorganisms that clean up pollution and restore damaged ecosystems. We must ensure that these technologies are used ethically and responsibly for the benefit of all humankind, not just a select few. Section 10. The future unfolds. The future of genetic engineering is filled with both promise and peril. It has the potential to solve some of the world's most pressing problems, from disease and hunger to climate change and resource scarcity. But it also raises profound ethical and societal questions that we must confront head-on. As we stand at this crossroads of scientific discovery and ethical responsibility, we must proceed with caution, wisdom, and a deep respect for the sanctity of life. The choices we make today will determine the course of human history for generations to come. Let us embrace the possibilities of genetic engineering while remaining mindful of its potential pitfalls. The future is in our hands. Let's make it a future worthy of our highest aspirations.